morning, good afternoon, good evening, whenever you're watching this. Welcome, fellow geometers. We're going to be talking about indirect measurement today. Now, what indirect measurement is when you can't measure something directly. I know that sounds really like a huge concept right there. I didn't really define it very well for you, but again, indirect measurements, things that we cannot measure directly. And so what we're going to do is we're going to use similar triangles in order to determine how to measure things indirectly. So let me give you an example here. If you go to your textbook online, you can actually see this picture right here of a person that's trying to measure this geyser here off to the right on that side over there. And obviously you can't measure the height of the geyser, but what this person's doing, and I know this is kind of a stretch, but you got to imagine this with me, because what they're trying to do is teach you how similar triangles are used, or can be used if you'd want to use them. And so what this person is doing is they've laid down this little mirror down here. Okay, you can kind of see that right there. It's a mirror. And through this person's eyes, they are looking down through the mirror and seeing the very top of the geyser. Now obviously, you move this closer, it changes the trajectory, and you're not going to be able to see the top of the mirror if you, well, I guess if you move it further away, you wouldn't be able to see the top of them. If you move it closer, you'd see, I guess you'd see a portion up to about there, so if you were continuing to move it closer. So what I want you to see from this is this. If you were to stay a certain distance from the base of the geyser, okay, so in this case it's 47.5 feet, and you were to place a mirror somewhere between you and the geyser in a certain location that you could actually look through that mirror and see the top of the geyser, you would be creating similar triangles. Now, how is that? Well, you know, the other day when we talked about the ways to prove similar triangles are either with angle, side, or side. In this situation, we would have angle. You are perpendicular to the ground. You are standing straight up and down from the ground. The geyser is shooting straight out of the ground, so you have congruent angles there. And the angle of reflection off of this mirror is also going to be congruent as well, okay? So what we're going to do is we're going to match up the corresponding parts from those two triangles to solve for the height of the geyser. And so you could say something like this: 6 over x, or 6 is to x, as 7 is to 40.5. Or you could say 6 is to 7, as x is to 40.5. Again, we're matching up those corresponding parts of those two triangles to determine what the height of that geyser is going to be. Now, if you look down here at the very bottom, they tell us that the geyser is 34, almost 35 feet up in the air. Okay, and so when you can't measure it directly by getting some kind of cherry picker out there and go right to the very top, it's a lot easier to use similar triangles to measure that indirectly. Another example I was going to show you guys, pulling up this picture right here, is let's see, work. Yep, very good. Okay. It would be measuring this cactus tree, or any tree in particular. And what I want you to see is, you may see the right triangle, right angle here, and say, okay, that's one pair of angles that are congruent, but I don't see two pairs of angles congruent, or a pair of sides that are proportional and make it side angle side. And so what I want you to know is that the sun is so many times larger, and I don't know off the top of my head how many times larger it is than Earth, but it is many times larger than Earth. So as a result, its rays, which, while the sun is circular in nature, okay, its rays, because it's so many times larger, are going to strike Earth pretty parallel to each other. And so this angle here and this angle here would have to be the same. Well, now you've got your similar triangles. And so we've got angle, we set up the proportion, and we can go ahead and solve for x. Now, I know you guys know how to solve proportions, so I don't want to waste your time by doing all of the work within the proportion. I just want to make sure that you know how to set them up, and then I'll let you guys take it from there. So again, what are some different ways you can set up the proportion? Well, you could say 6 is to 4 as x is to 9. That would definitely be a proportion you could use. You could also flip-flop this. Okay, 4 is to 6 as 9 is to x. That's completely fine. But the key is that the 4 and the 9 have to correspond, and the 6 and the x have to correspond. And we see that right here. Okay? Now, another way you could set it up would be the 6 and the x correspond, do them vertically. We come back to the original triangle, the 4 and the 9 correspond. You notice here, we talked about this earlier, that the cross product of these two, let's see here, 4x is equal to 54, 4x equals 54, you know you've got the same answer either way. And so just making sure that you know how to set up those proportions. Now there are a couple other examples that I would like to look at with you guys because they are going to be very important for what we're going to be doing moving into the future as far as similar triangles are concerned. And so I'm going to ignore this example off to the right because I think you guys could do that pretty easily. It's this example off to the left that I want to make sure that you'd be able to set up correctly. And so as we look at this picture of the two triangles, the first thing I want you to ask yourself when you're doing any of the practice problems tonight is, how are the two triangles going to be similar? And if you can't prove it, then you shouldn't set up a proportion because obviously the proportion might not be true because the triangles might not be similar. And so I'm going to go ahead and mark the vertical angles are congruent. I told you guys that back in chapter 3. When you start to see images that have vertical angles, always mark those congruent. Continue that same process. Don't stop that. Now, I'm then going to match up the smallest side from this triangle with the smallest side that I visibly know from the other triangle. So I know that 10 is smaller than 15, so I'm going to match up 8 to 10. And I'm going to ask myself if, well, 12 is the largest one that I can visibly see, and 15, as far as I know, is the largest one that I can visibly see there. And so if I match those two up, let's see here, it'd be 12 to 15. Again, I'm starting with the smaller triangle going 8 to 10, so I'm going to do 12 to 15. If I can cross multiply, or if I can reduce the fractions down, we're going to have the exact same ratio, hopefully. If we don't, then we can't set up proportions. So if I reduce this down, I have 4/5, okay, dividing both those by 2. If I divide both these by 3, I also have 4/5. So it's a good thing. We've got the same ratios. If I take the cross product, that's 120. 80 times 10 is going to be, or 8 times 10 is 80. 8 times 5 is 40, so 80 plus 40 is also 120. So we know that we have the same ratios here. And so as a result, these two triangles are similar by side, angle, side similarity. Okay? So we've got that nailed down. Now, how do you set up a proportion from there? Well, I would encourage you guys, pause the video for a quick second and see if you can set up your own proportion. Okay? So I'll let you do that. All right, hopefully you set up your proportion, and here's what I'm going to do. There's lots of different ways to set this up, but I'm going to go ahead and say this. If I was to take 8 to 10, okay, smallest side with smallest side, and I know that this side x corresponds with this side 11, because we've already talked about these two sides corresponding to each other, I'm going to go ahead and do this. 8 is to 10 as 11 is to x. Okay, that would be one way you could set up your proportion and solve for x within those similar triangles there. Okay. Another way to do it, you could also go ahead and say this. Let's say 12 is to 15 as, again, going back to this triangle, 11 is to x. Okay. Now before I continue on, if you have a proportion that's different than one up here that I have, I would encourage you to cross multiply and solve for x, and then solve for x within one of these proportions. If you have the same answer that I came up with up here, then you know you had the right proportion. There's no way to set it up and not have the right proportion. Now I will tell you one last way to set this up, and that's to use the similarity ratio between the two triangles. We know that the similarity ratio is 4 to 5, okay? Or that this triangle is 80% of this triangle, okay? 4/5. And so as a result, you could go ahead and do this. 4 is to 5 as 11 is to x. Or again, the reciprocal of that, to go ahead and flip those two, would also give you the same proportions there. So really hope as up to this point, nothing's been too earth-shattering, because most of the time students grasp that part pretty quickly, okay? This next part is what I really need you to pay attention to, because when we have overlapping triangles, usually students struggle a little bit, okay? And so here's what I want you to do. I want you to redraw this triangle, okay? this triangle on your piece of paper separate of any of the other triangles, okay? Or any other work that you have. All right, now, what I'm going to do is I would like you to go ahead and separate those two triangles from each other, okay? And so if I separate the top triangle, just so that we can see it correctly here, I'm just going to sketch it down, 12, 15, 17, okay? All right. And then if I separate the other triangle, here's what we have. We have 12 plus 8 is this side, so 20. I have 15 plus y is this side, so 15 plus y. And then this side is going to be a length of x. Okay? Now what I should have done before we got started with this one is made sure that you understood that this length right here and this one right here are parallel to each other. If I don't show you that that's parallel, there's no way to prove the two triangles similar without that information. Okay? So how do we know the two triangles are similar? Well, we know that this top angle is congruent in both triangles. Okay, so I'm going to mark those two congruent. I'm then going to mark, with the lines being parallel to each other, I'm going to mark these corresponding angles congruent. Now, it doesn't matter if you do these two or these two, but it's important you recognize that we have two triangles similar by what we call angle-angle similarity. Okay? Now that we have that, we can actually go ahead and set up our proportions. Now, maybe I should backtrack. The similarity ratio between these two triangles, if I match up the entire one side of the one triangle, so I know this 12, I know this 15, I know this 17, but of the big triangle, the only one I know is this 20 right here. So if I match up the corresponding sides there, 12 to 20, okay, and I reduce that down, dividing both those by 4, I get 3/5. Okay, 3/5. So as I said before, this triangle is going to be 60% of that triangle because 60% is 3/5. Okay? And so one way you could set up to solve for either x or y would be to go ahead and match up the corresponding sides, 12 to 20, and match that up with another pair of corresponding sides. Now, if you're solving for x, the corresponding side with x would be 17. And so since we started with 12 here and went to 20, you're going to start with 17 here and go to x. So 17 is to x. Okay, that's how you would set up to solve for x. Now, what's the value of x? Irrelevant. I know you guys know how to do that. The key is, can you set that up? And so what I really want to stress to you guys is this. This stuff that I'm giving you right now is not rocket science. It's not hard, but it takes a little bit of effort. It does force you to go ahead and redraw the two triangles separate of each other. So on every single homework assignment that you have tonight, I want you to redraw the two triangles separate of each other. Okay? I will be looking for that if I collect that homework assignment on Friday. I want to see both triangles separate of each other. Now for the y value, what I'm going to do is, again, I'm going to go back to the original ratio. I'm not going to take what I get down here because it's very possible, even though I know you guys know how to solve these proportions to a high degree, is it possible that we can make a miscalculation along the way? Yes. So why would I want to use what could be, I'm not saying it is, but what could be errant information in order to come up with another variable? I don't want to. I want to stay away from that. And so as a result, I'm going to use 12 to 20. I'm going back to my original ratio, which I know is true, is as 15 is to 15 plus y. Okay? Now please, when you have this type of ratio, please make sure you distribute the 12 to both the 15 and the y as you're going in and solving that. Okay? So again, not too concerned about how to solve the proportions, just wanted to make sure that you know how to set up the proportions within that problem. It's going to reinforce, whenever you have a proportion or similar triangles that are overlapping like these two were, I want you to draw them separate of each other. It's really going to help you out. Okay? All right, now for the last one, taking a look at this last practice problem right here, I'm going to go ahead and again have you draw that picture out. So take a moment and go ahead and draw the picture, label all the parts to it. You may want to pause this because I want to keep moving on. Okay, but draw that out. And then I want you to draw it separate, and I want you to label all parts correctly. Okay, and then see if you can solve for x. Okay, take a moment and do that. When you're ready to listen to me re-explain everything again just to make sure you got it, you can press play and we'll talk about it. So go ahead and do that. All right, so if I redraw the two triangles separate, like the last one, these two triangles have a vertex angle that's the same, and we also have a pair of corresponding angles that would be the same as well. Now again, do you have to mark the same corresponding angles that I marked? Could you mark the other pair? Completely fine with that. Just make sure you have one of the two pair marked. This length down here we know is 8, so that's easy. This length over here, make sure you don't get this part wrong. We're taking the 4 plus the x, not 4 times the x that I think a lot of students like to put down. Okay? So hopefully you went ahead and set up your proportion. You could do something like this. Doesn't have to be exactly 3:8, matching up those corresponding parts, as 4:4 plus x. Okay, and again, don't forget to distribute the 3 to both the 4 and the x there. Okay, so you've got all the information there. I believe that's everything that I wanted to go over. If any of this did not make sense to you, please talk to me in class. Outside of class, it does not matter. I would love to chat with you about similar triangles and how to set up proportions. Unlike proofs, and I understood proofs are difficult and abstract, and you got to remember a lot of things. With similar triangles, they're not hard, but I see a lot of students that sometimes struggle with them. And so don't be afraid to ask. All right, so good luck on your homework tonight. It is online. Make sure you check your calendar, and I will see you tomorrow. Good night.